So what I'm supposed to do is basically a recap of yesterday. If you really talk about these goals, describe the end behaviors of polynomial function. Well, we did that, except we did it with a thing called a limit. Do you remember the limit deal? Another one of our goals is find the zeros of polynomial functions. Okay, so that's the x-intercepts, and that's usually just factoring. Okay, and then graph polynomial functions. Well, we did that before, but remember when I just said, here, let's make a sketch. We know this end goes up. We know this end, goes down. And it's got to like bounce off of here. That's a sketch. How do you make a sketch into a graph? You have to have a few more points that are labeled. Like you'd have to for sure know the x-intercept, which is like this number. And this number, those are the x-intercepts. You'd have to have the y-intercept correct on there. And just having more labeled points makes it a graph instead of just a sketch. So like if I told you this is a 7, and this is a -3, and this is a 5, you'd be able to make an exact graph for that. All right. So just to start with, would you please just copy this little sketch right here? Just copy that one. Sketch that on your own iPad. And then the job is try to make an equation for that. Start with y equals. I need to pause for a second because a lot of kids are still copying this. I'll pause. Okay, so I hope you have a parenthesis for each of the zeros or roots. So if I tell you that there's a 7 for an x-intercept, I know there's an x minus 7. Know what I mean? Because the 7 here has to make the equation equal 0. That's what they're called. They're called zeros. They're also called x-intercepts. They're also called roots. But then I'm going to take this -3 here and put it in as x plus 3. Make sense? All right. So now, would this one have a y-intercept that was right? What I just wrote would not have the right y-intercept. I'll tell you why. Because the y-intercept is where x is 0. I stick in a 0 here and a 0 here. And then I say, okay, this would be y equals 3 times -7 makes y equals -21. So what is going on? Why isn't my graph working? I'll give you a hint. There's a bounce. Remember how this is bouncing there? Did you remember that? You learned this in higher algebra. When it bounces, that means there's a squared right there. Is that coming back? You did do this in higher algebra. I guarantee it. I've taught that class forever. So when there's something squared, that means there's a bounce, like that. Okay, so when the graph, it looks like a ball, came down and bounced off the ground and then came back up again there. That kind has what's called a multiplicity of 2. And now when I do it, this 7 and this 3, when we put in the zeros, we put a 0 here and a 0 here. Now it's -7 squared, which is 49. And 49 times 3 gives me a new y-intercept. The y-intercept is where x equals 0. I think that's right. 120 plus, I just used 27. 120 plus 27. See, what I'm doing is this. 3 times 40 plus 9, because 40 plus 9 is 49, right? So I do the 3 times the 40, which is 120. 3 times the 9, which is 27. 120 plus 27, 147. There we go. I just couldn't, something was wrong. Okay, so this must be 147. All right, if you understood that, I know this is kind of a stretch. Maybe you're ready to do one yourself, maybe not. Let me just show you one more thing. This one's going up on the right. Do you remember that deal where that means that there's no negative in the front? When they go up on the right, that means that the lead coefficient is positive. There was no negative in here. If it was going down on the right, you'd have to throw a negative in there. Now, that's a really nasty way to catch people, because otherwise, you draw the graph, you go like this, and then nobody remembers that it's going down on the right. There needs to be a negative in the equation. I'm just going to show you super quick how I would be able to do this problem. If that's -1, and this is 5, and this is 8, you don't even have to copy this one. Just watch and pay attention for a second. I'd need a parenthesis for each root. This -1 gives me x plus 1. This +5 here gives me x minus 5. And this 8 here gives me x minus 8. And then the sad thing is I'd be wrong for 2 reasons. One is that it's going down on the right. That means there needs to be a negative in the front of the whole thing. And number 2 reason it's wrong is because there was a bounce right there. So that one needed to get squared. And now I've got the right equation. Do you feel like you could do that? It wasn't that bad, was it? You know, you got a parenthesis for each of these. The only one that was a bounce had to get squared, and it's going down on the right, so it needs negative in front. All right, see if you can do it. Here's one. Let's make a little sketch. We'll make it like a W. Boing, boing. And this is at -3, and this is at 6. Tell me what equation that would be. Marking Claire and Kai as absences for today. Arrow, can you tell me what the equation is?
Y equals x plus 3 squared.
X plus 3 squared, and then what?
X minus 6.
And x minus 6, and that's also squared because they're bounces. And did you even look and see if it was going up on the right or down on the right? Because if you thought about it, then you win. But if you didn't even think about looking to see if it was going up or down on the right, you wouldn't know whether to make this negative or not. See, if it's going down on the right, I'm telling you, we often do that on the test. It'll be going down on the right, and you'll be like, I didn't even notice that I needed to make it negative. Yeah, there would be a negative there if it was going down on the right. Okay, cool. Now, if I needed to know what this spot was, it's called the y-intercept. So x equals 0. If I was wanting the x-intercepts, you set y equal to 0. But this is the y-intercept, so you set x equal to 0. And this one's kind of a nasty one because it gets so big. 3 squared, 9, times Negative 6 squared, 36. So it would be a huge number. We probably wouldn't give you one that big on the test because we don't allow calculators on the tests. Okay, so then, I mean, 9 times 36 isn't that bad, but, you know, we probably make them smaller. 9 times the 30 makes 270. 9 times the 6 makes 54. Put it all together. I know I'm doing it different than you probably would have done it, but it should be 324. Okay. Let's go. Zeros of polynomials. Zeros are the same as the x-intercepts. Finding the zeros is the same as finding the x-intercepts, or the roots, or the solutions. Look, 4 names. Zeros, x-intercepts, roots, solutions. Okay. You can factor it and use the ZPP. That's this way. What if you can't factor it? Then use the quadratic formula. We've done this a bunch of times, but I still think it'd be good practice. Everybody go off to the side. Please write this. Y equals x squared minus 9x minus 10. If it factors, factor it and solve it. If you can factor it, you should. If you can't factor it, use that quadratic formula. Garrett, does it factor?
Yeah.
You are correct. What did you get?
X minus 10, x plus 1.
And the way you know you're right is by going the outside and the inside. I call it the smiley face of factoring. This is 1x, this is negative 10x, and together they make negative 9x. That's how you know you're right. Okay. And then I found the x-intercepts. That was pretty easy. All right. Do you remember over the 2 days I was gone, through video, I tried to teach you how to factor by grouping. Everybody write this one down. X to the third plus 2x squared plus 5x plus 10. And we decided that that was a good skill to teach right before Thanksgiving because we needed something that we couldn't give you homework on it because the principal wanted, and I understand and respect that call, to not give you any homework over the 4-day Thanksgiving thing. So we needed something you could do that you could get all done with right before Thanksgiving. All right. So, and this wasn't super important to us that you learn how to factor by grouping. Like if you mess that up, we could probably pick it up later. So I'm just going to remind you right now. Do you remember that this had an x squared in both of them? And then you factor out the rest? Go ahead and do that. And then this has a 5 in both of them, so factor it. You like think of it as 2 separate factoring problems. Do you think it's a coincidence that they both came out to an x plus 2? Not a coincidence. I set it up that way on purpose so that you could factor it again. So now you look back and go, oh, these both have an x plus 2 in them. So you factor it out to the front. And once they're factored out to the front, this is gone and this is gone, and I have x squared plus 5. Raise your hand if you had that one right. Okay, awesome. Now, let's just analyze these for just a second. If I said, what are the x-intercepts? You go x equals negative 2, you know, the thing that makes it equal 0. And this one, you'd go x squared plus 5 needs to equal 0. X squared is equal to, I'm subtracting 5 from both sides, negative 5. How the heck do you square something and have it equal negative 5? You can't. And so that means that this is got imaginary solutions. Have you ever heard of that? Square root of a negative. See, when I square root this, And now just literally yesterday in higher algebra, I was grading tests that had this on there. And tons of kids forgot that the square root of x squared is the absolute value of x. And I bet a lot of you would have forgotten that too. And the square root of -5 can be simplified by taking the negative out and calling this I for imaginary root 5. And then your final answer gets 2 answers. Whenever there's an x squared, you should know there's going to be 2 answers. Sometimes it's 2 of the same answer, but anyway, now I have x equals I root 5 and x equals -I root 5. So my solutions for this equation are this and that and that. And there's 3 answers. Why? Because it was an x to the 3rd problem. Holy cow, there's so much going on in this math class. We're in pre-calc. This is the reason that pre-calc's hard. You never have a day like this in FSC, but you guys wanted to take this class, which is cool. Glad you did. So we started with this problem that was a cubic. That means there's 3 answers. We factored it, because if you can factor it, you should. Then you know that that one can be made 0 by using -2. So that's one of your nice, clean, simple answers. This one, you had to figure out what makes it equal 0 by setting it equal to 0, square rooting, remembering this little trick, which tons of kids forgot, even in my honors higher algebra class on our last test. And since it's an absolute value, that brings you 2 answers. And you had to know what to do when there's a negative underneath the square root. See, pre-calc involves like 17 different things you have to know at the same time. So there's my 3 answers. This one was a real answer. This one and this one are imaginary, meaning I can't see them on the graph. You can graph this function, but you can't see these answers because they're imaginary. They're like leprechauns. You might know they're there, but you can't see them. Okay, so let's go to this page. This is the 3rd page of the notes. Do you agree that factoring is a big deal? It's happening again. If you can't factor on this next test, you're toast. Because the first thing you do on this problem is you factor it. Because if you can't factor it, you won't know where the x-intercepts are. So factor that thing. And the first step in factoring is looking for a GCF, greatest common factor. What's in all 3 of those, Garrett?
What's in all 3 of those? X.
X is. Factor it out. Just take an x out of each of them. Iris, what do you have left then after you just take out an x?
X squared.
Yep.
Minus 2x.
Yep.
Minus 15.
Nice. And then, I would bet you that this is going to factor again. Alex, have you got this one? Okay. I'll walk you through it. First off, put the x and the x in there. Next, we got to think, what signs do we want? Can it possibly even be plus and plus? No. That can't be plus and plus because we have minuses in it. Could it be minus and minus? If it was minus and minus, this would have to be positive. You know, because you're going to multiply the 2 negatives together. So it can't be minus and minus. It has to be a plus and a minus. See how I used logic there? I have to have 1 positive and 1 negative. And Trent, can you finish what those last 2 numbers are? Give me some options to multiply to 15.
5 and 3.
Does 5 and 3 also maybe make a 2?
Yeah.
Ah, so I'm not sure, but you said 5 and 3, so I'll put them in the same order you said. How do I check it now, Trent?
You multiply it all.
All right, now the x times x is x squared. I encourage you not to even multiply that out because we all know it's going to be x squared, and that's good. It's these 2 that matter. So, Trent, what do the outside ones make?
The outside is 3x.
Yep, the inside.
-5x.
Put them together,
-2.
and that's what I wanted. Sweet. Now that I got it factored, you should be able to graph it. We just practiced this. You should be able to do this. graphing this thing. Claire, name a important spot that it has to touch. -3 is, for this one, you are correct. So here's -3. I put a nice big dot there. Now give me another spot, Claire.
0.
Good. That's one of the harder ones that a lot of people don't get. Because do you get the whole point is try to make this equation equal 0. And if you stick in x is 0, this spot turns the whole thing into 0. So x equals 0 is one of your answers. So that has to touch right there at the origin. All right, Dominic, the last one. That one's 5. Those are called the zeros. They're right there. There's 3 of them. Was there any bouncing going on?
No.
No, when you look at the factored form, there is no squareds here, here, or here. So there's no bounces. Was there any negative in the front? No, so that means it ends going up. From there, you should be able to finish this thing. Draw the line through the right places. If it can't bounce, it has to go down through it. And it can't bounce, it has to go up through it. It can't bounce, so it has to go down through it, and there you go. And then they have one last question. What's the y-intercept? Well, now that I got the graph, it's easy. I can just look. But otherwise, the y-intercept, you set x equal to 0. And if we do that, put in 0 here, here, and here, you'll figure out that y equals 0. Or I could just look at the graph and see y equals 0. So 0. But if I just put 0 there, that's called a bald answer. Just a single number answer is almost never right. So the y-intercept is where x is 0. 0, comma 0. Why is that better? Because just a number is too vague. You're in a 2D graph, 2-dimensional. If you just say the number 6, where the heck is that? In 2 dimensions, you don't know. You don't know if you mean x is 6 or y is 6 or a circle with a radius of 6. I mean, 6 is just too vague. So on your pre-calc answers, if you ever find yourself just writing down a single number, like 2, question it, because in 2 dimensions, where's 2? Can't really tell. Okay, so 0, comma 0, that gives me both dimensions. That's much better. Okay. This last word that I haven't talked about, extremes. Extremes are really high or low points on a graph. In politics, extremes are people that are way on the right or way on the left. Okay? Like if you're extreme at anything, I don't know, if you're extremely tall, people notice because you're like, holy crap, that person's extremely tall. Or if you're extremely short, again, people notice that and tease you about your height maybe. Well, what's extreme about this graph? That spot and that spot. Okay, and we have names for those. This is called a max. But it's not the max of the whole graph. It's not the highest that it ever went. It's called a local max. And this is a low spot. It's not the lowest that the graph ever went. There was spots over here where it was lower. So that is called a local min. And last but not least, the research shows that if I make you try to remember this from yesterday, that you will do it, you'll remember it better than if I just show you. Try to remember how to write the limit statement for something that's going up on the right like that. For sure on your next test. Lim, and then there was a bunch of other little things. Arrows, f of x's, infinities, negative infinities. All right. The limit of the function as x approaches, well, look, if I go on x here, if I keep going over, I'm going way to the right, so x approaches infinity. If I was over on this end, x would be approaching negative infinity because you're moving your x like this way. All right, but I was on this end, so x is approaching infinity, and then I put an arrow because you can never touch infinity. If you said equals infinity, I understand. I used to make that mistake. Literally this year, I was told that on the AP test, you can't do that. Trent, I'm sad to see that phone. You got to go put it up in phone jail. All right, so I'd like you to see if you remember how to write limits well enough to tell me if I make this one, don't even draw the graph. Just tell me the limit on both sides. The limit on the right and the limit on the left. Let's make sure that you remember how to do limits. Tully, can you tell me the right side limit? This one right here. Lim. And what do I do next?
F of x.
Yep. Every single time ever, you'll always have that. And then what's underneath the lim?
X.
Every single time, you'll always have that. And then what's always after that?
An arrow.
Correct. And for the right side, what is x, which is this, approaching?
Is it negative infinity?
Watch my x's. Watch my x's. See what I'm saying?
Yeah.
It's positive infinity. And I know it's going down, so I get that there's that feeling like it should be negative infinity, but that's what the y is. The y value is going down, 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 down. So if I check which way is it going in the y direction, it's going down towards negative infinity. Sean Nunez, would you please do the other limit? Start with lim and go from there.
F of x,
Correct. Underneath the lim?
x towards negative infinity.
Correct. And this last one? Right here?
Towards negative infinity.
Towards negative infinity again. And if you're not sure, I like to think of it as like if this was a point, if I extend it in my head forever, it would be going towards negative infinity, negative infinity. It's way this way, which is towards negative infinity, and it's way this way, which is towards negative infinity in the y direction. So it's like a point like that, so they both are negative infinity. There's no point of this. I'm totally, in fact, I'm sure some high-level math teacher would be like ticked that I'm even saying, putting it in a point form. I know, there's no point for that. But it, I think, helps people to know what the x number should be and what the y number should be, to think of it kind of like a place, but you can't actually get to this place. Okay, cool, we're on. This is page 4. If you can factor it, you should, and you can. If you know what you're doing, you'll be able to factor this thing. It's just not the easy kind. So George, it has to start with something, and it can't be x and x. Think it through. He has to make it 3x squared, so can't be x and x. That would just make x squared.
3x.
There you go. 3x and x. All right. Mason, it cannot be plus and plus on the inside. What could it be?
Plus minus.
Yes, has to be a plus and a minus. Because that number is negative. That's all you have to hear is this number is negative. We don't even care what the other one is. If the last number is negative, it has to be a positive times a negative to get that. So it has to be a plus and a minus. An RB in the back corner. Rhythm and blues. Tell me. What multiplies to 4? You got two choices. Could be 2 and 2. Let's check it and see if it works. You check the outside, and what do you get? Negative 6x. What do you get on the inside?
Plus 2x.
And together that makes negative 4x. That is so close. Do you get how I got positive 4x here, but I ended up with negative 4x? So what do? Switch the signs. Very good. You don't switch the numbers, you switch the signs. Now I know in this case 2's, if you had moved the 2's, it would have been irrelevant, right? So obviously you can't just switch the numbers. You'd have to switch the signs. So if you ever get the opposite of what you wanted, then you switch the signs around. And then this becomes positive 6x, this is negative 2x, and then you get what you wanted. Do you see how factoring is still a big deal? That's why I started the year with the basic 20, one of which was factoring. And then we moved up to even harder factoring, and now it's happening like every day. You cannot forget how to factor. All right. Now that I did that, one of these is still easy. This one is just negative 2, so that's easy. I just put a negative 2 on the graph. But this one's not as easy. Well, you just got to go 3x minus 2 has to equal 0, and you solve it. You figure out what that x must be. It's a fraction. Chrissy, walk me through the steps of solving this little thing. Plus 2, and then I get, and then, very good, x equals 2/3. Where is 2/3? Well, you're just putting marks on a graph to put 2/3 somewhere over here. I don't know. If you wanted to number it all out and find out perfectly where 2/3 was, you could, but it's always an estimate anyways. You're going to go about 2/3 of the way to 1. So I'm going to say that's 2/3. And are either of these squareds and therefore bouncing? No, there's no bouncing. And is there a negative in the front? Nope, so it's going up on the right. So then there's only one way this can go. Ga-doing, ga-doing. Now, if this was a different unit, I'd ask you what the vertex was, and you'd go x equals negative b over 2a. Doesn't that seem like forever ago that you did that? But that's on the final. So if you're ever like, oh, I'm glad I don't have to remember that anymore. Remember that the final is coming, and the final is cumulative, which means everything we've learned this year. So if you're ever stuck on something that's old like that, just walk up and ask me. I will happily remind you because it'll be on your final. That's how you get the vertex. Now, I'm not asking you to do it right this second. I'm just reminding you. That's how you get the x to the vertex. We could do that. Here's A, here's B, and here's C. And we could get negative b over 2a and figure out, oh, that dotted line runs right down the middle right there, and then figure out the vertexes. How many zeros did it have? 2, and that's easy because there's 2 answers because of that. How many extremes does it have? It's only got one low spot right there. And that's a low spot, so we call it a min. It is the lowest of them all. If it was only locally a low spot, like around its neighborhood, it's the low spot, then it would be called a local min. But this is just the low spot, so we call it a minimum. That spot right there is the minimum, the low spot. And there's only one extreme. Does it ask for the number of extremes? Only one. Doesn't even ask us where it is. Just wants to know how many lows or how many low and high spots are there. And you might think of these as high spots. They aren't. They're going to go up forever. They never stop, so they're not a high spot. There's no maximum. This keeps going. Okay, now, the only thing hard about this is the factoring's a little harder. And frankly, I feel like this is the part where you're a little burned out, and I probably can't get you to pay attention much longer, so I want you to get you started on the homework instead. I would just show you if I took x squared out of this, then I'd have x squared minus x minus 6, and then I could factor it again. And it would just be like all the other ones, except what the heck is that? That just means it goes through 0, because 0 is the root there. And this one would be like x minus 3 and x plus 2. So it would touch at 3, and it would touch at 2, and it also would touch at 0. All right, don't put your iPads away quite yet. I want you to just open the homework. We're going to be leaving very soon, but just open your homework. Because if you don't open the homework during class, you're not going to open it up. If I get you started, then that increases the probabilities you will get it done dramatically.
Scroll up so I can see them. Is it just this one? Oh, way too many.
All right. Holy simoleons. Just do the evens on the first 2 pages. That'll cut it down a tremendous amount. Just the evens on the first 2 pages. Be nice to yourself. My gut says we're going to have this assignment for 2 days. If you just skip it, you'll have to do it all tomorrow. Evens in the first 2 pages. Have a great day. See ya.
Thank you.